Welcome to this talk. My name is Seyed. I work at Cisco Security, and it's about why you should avoid INT sync. It's based on my experience building INT services for Cisco. I'm gonna give you a fictionalized version of what we learned. So meet our heroes here. Zoe and Chloe are both devs, but they live in two parallel universes. They were both tasked with creating authentication services for respective companies. The requirements were the same, but they ended up building very different systems. Let's start with their stories. Start with Zoe. So once upon a time was a very smart developer, a hedgehog called Zoe. She'd been working on a service called Boost, and that service provided hedgehogs with health and safety information. It was built using Ruby on Rails. Customer could buy licenses to have their information there, and when their license was processed, a record of a business was created, and then they could add multiple users there. And the users could log in and have access to the services of Boost. So Zoe was a happy hedgehog because over time, more and more customers bought Boost, and there was an increase in income and more users. But over time, a portion of those users start to ask, why should they have yet another password in another system? So initially, they needed to create a user account with their email as their user ID and save a password, which was saved in the Boost database. But they had other accounts elsewhere. So why couldn't we use the existing accounts we had elsewhere in our companies? So Zoe decided to implement a service that's called single sign-on. And the way that it works is like this. So Boost supported single sign-on using a different identity provider. So Boost could be its own identity provider if the users decide to save their own password there. But if they had another identity provider, the identity provider could be registered with Boost. So the users start to go through the login page of Boost. They chose SSL login. Boost redirected them to the registered third-party IDP. So the user authenticated there. The IDP returned with a response. The format of XML is called a SAML response, and sent it to an endpoint of Boost that was registered with the IDP, which in SAML language is called the ACS. So that endpoint would process the SAML response, and if the SAML response was valid, they would redirect user to the main page of Boost because they logged in. So this was very successful, but there are more products or services under the main company that own Boost. The top managers were deciding that they had something a similar issue because each of those services they had their own user and passwords, and users they needed to have separate logins and passwords in different services. So they thought, why do they have to do this when they can actually have a centralized place for authentication? So Zoe was tasked to create such a service. So the new service would be the identity provider to multiple products or services, which are called service providers. So what Zoe decided to do was to start with the existing logic that existed in Boost. She decided to extract all that logic out into a new application. She called it BoostAuth. So there are two main models there in Boost. The user email as their username and their encoded password, and they belong to a business. But Zoe decided that she wanted to have a separate or new database. But she didn't like the way the passwords were encoded in Boost. She wanted to use a new encoding scheme called Hedgehog Creep 2. But since the passwords were encrypted inside Boost, she couldn't actually read them back. So what she decided to do was to have the new system access to both databases. So she kept the models from Boost and she created new models for the new database called BoostAuth database. And it's a Rails application, you can't have the same model names. So you decided to name the new users for the new database as Hedgehog and what's represented as business in Boost as organization. So what happened was when a user logged in through BoostAuth for the first time, if they had a record in Boost database, they're authenticated against that. But at that point, BoostAuth had the non-encrypted password, so they could actually save it in the new database as well. The new record was created, the same email, same UUID, same password, and also an organization was created. So it's a one-to-one relationship between a hedgehog and user, an organization and business. So that was the initial thing, but that wasn't the plan for the long term. Zoe wanted to actually separate the new application from the old database. But to do that, she needed to create some services for Boost because Boost still had its own pages to manage users. Zoe started to go through different options. And one of the options that she looked into deeply was a standard called SCIM, which stands for System for Cross-Domain Identity Management. It had multiple RFCs, and she saw that some famous websites started to implement some of that and support it. So she decided that's a good start because that was a standard. So what SCIM provides was a few models and few operations. So the basic models are user and groups, and operations are base CRUD operations. It also uses JSON representation for both resources and the operation endpoints. Zoe started to look to see if there were some implementations for that, but no Ruby implementation. She was a star developer. She was like, okay, I'm gonna build my own. Started reading RFCs and decided to implement Skim. But some parts of the Skim standard was very complicated. So for phase one, Zoe decided, all right, gonna implement a subset of the Skim that will allow services like Boost to talk to the new service. So after that implementation was in place, those two services look like this. So BoostAuth still had access to the Boost database and its own BoostAuth database. And there was the Scheme API, which Boost could use. So the plan was inside Boost, if they try to use the pages to add or remove users to different businesses, would call a Scheme API, which would save it to BoostAuth, and then Boost could save the stuff in Boost database, which kept the information in both places. And eventually, Zoe and her team could remove the dependency to the old database. In the meantime, developers for Boost, they had to work on some other stuff. There were other requirements. So they didn't have time to actually implement Skim integration. But in the meantime, managers ask Zoe and her team, can you support another service? They don't have anywhere to authenticate the users. And Zoe was like, oh, why not? We implemented Skim so they can use that. So that new service was called BoostGraph. And they told Zoe and her team, all right, we're going to use your Scheme API. Zoe decided these users, they are not probably going to use Boost right away. So what we're going to do is we're just going to create them in the new database. So that's how that integration was built. So that BoostGraph and Boost. So BoostGraph talked to Scheme API. Boost did not. So over time, some users started to add themselves on BoostGraph. So let's say it's a new user with this email address as their username. So they added themselves on BoostGraph to a new customer. So it went through the Scheme API and it was added to the BoostAuth database. But the UUIDs were generated by BoostAuth, so they had their unique UUID for the user and the organization. Same time, or sometime after that, the user decided, oh, we also had the license for Boost. I want to have access to Boost as well. So they asked admin there, can you add me there? So they added them in Boost, but Boost didn't talk to BoostAuth. It had its own internal UUIDs for a business and a user. So these users were added. They belong to an organization and a business in two separate places with different UUIDs. So how to manage these? Because initially the design was businesses Boost and organizations BoostAuth are going to be one-on-one. But now we have an organization which was supposed to have a business in Boost but didn't match because the UIDs were different. So to avoid this, Zoe decided, all right, I'm going to make sure that the user with the same username, which was their email address, should belong to the same organizations and businesses. She added a validation that was applied during authentication. The user was found in the Boost database using that email address and the BoostAuth. And the UUIDs of the user and its counterpart, which is called a hitchhike, was compared. So if the UIDs matched and the business and or UIDs matched, it's like, oh, it belongs to the same business and org. Everything was fine. Otherwise, there was a validation error. But what happened after this change was released? So a lot of users started complaining. Like, oh, I used to be able to log into Boost, or I used to be able to log into BoostGraph, and now I can't access any of those. So it was like, what just happened? Need to investigate some more. So after looking into this, Zoe decided the main reason was that Boost didn't talk to BoostAuth, but BoostAuth was reading from its own database and the old database from the Boost application. But when new users were added in BoostAuth didn't know anything about that. At the same time, when the users added through a skim, it didn't actually check in the Boost database. It was just adding them in BoostAuth. So to make sure that the mismatches wouldn't happen again, Zoe and a team from Boost, they decided that they need to change the logic when users are added in Boost. So they started to call a scheme API when users were added. So if the user with the same email existed but belonged to an organization with a different UUID, it wouldn't allow them to add it in Boost. Say, okay, there's some mismatches. But the admins for those customers, they start to ask, why can't I add this user? It just tells me you can't do that because of some mismatches, and I don't understand what they are. So there are more and more requests to fix this. So Zoe needed to go and move users from this organization to the other one that matched the business in Boost or vice versa. So a lot of manual synchronization was needed. So life wasn't as happy as it used to be when she just worked on Boost. Another nightmare scenario that happened was updates. As Boost had the page for user changes, users could actually change their user name, which was their email. So, okay, I don't want to use this email anymore. I just want to change it to something different. But that email address was shared between different services as well. So it was another nightmare scenario. What if they update in one service? What should we do? Should we update it in the identity provider and then just call the other services to update as well? A lot of sync needed. Why did we start like this? Zoe wasn't happy at all. Now, let's go to Chloe's world. So as I mentioned earlier, Chloe lived in a parallel universe. It's kind of a doppelganger for Zoe. She worked on Boost in this universe, and she was asked to build an IT provider. And the requirements, or the initial requirement, is pretty similar to Zoe started with. But Chloe was a magician. She had a secret weapon. It was a time device. She could travel time, travel to the future, and see what would happen in the future based on her decisions. So her initial ideas were very similar to Zoe's. Said, let me travel in time and see what happens if I choose to implement stuff with two databases, extracting out an authentication service that have access to those databases and implementing a scheme. So she traveled a couple of years in time and she was back. It's like, oh Haglet, the future wasn't as good as I anticipated. Hedgehogs had to stay home and work from home all the time. Toilet papers are the hottest commodity. And a lot of users couldn't log in. They weren't happy at all. So, my initial design decision didn't work out too well. So, she looked at what went wrong. And she figured there were a few things that made life miserable for her future self. So she wanted to avoid that. So those things were first one was the identity replication, which Zoe had learned about it in a very painful way. That identity related information was replicated among multiple services, the IT provider and the service provider. And they were also changeable. So if it changed in one place, they had to be synchronized in many different places. The second one was having multiple databases, keeping things in sync between those two databases. So the initial idea was to implement Scheme and get rid of the dependency to do databases. But things didn't pan out the way that she anticipated. So the dependency to two databases stayed there for a long, long time. So she didn't want to go through with that decision. A third one was kind of a subset of the first one, that the user ID was updatable, but because it was replicated, it needed to be updated in multiple places. It could create difficulties if the updated value existed in a different organization. The initial design didn't support such a thing. The user could only exist in one organization. And finally, choosing scheme. Since there was no implementation for scheme, she had to implement a subset of that and needed a few months to do that. But in the future, she realized the scheme didn't actually help her much. It could have just avoided the whole thing and spent time on other factors, made sure she didn't have any of those issues. So Chloe told herself, Now it's time to change the initial designs. They didn't work out in the future, so I'm just gonna go with some different designs. I learned a lot from the future, so I'm not gonna make the same mistakes again. Now let me go with a new set of design, and I can travel in time one more time and see how it worked out. So her new design was something like this. So she wanted to extract the authentication logic out of Boost, but she didn't want to rely on two databases. So what she did was to copy all the data from Boost database to the new database. So she had the old version of encrypted password with Hedgehog Crypt 1, but she had the new column for the newer version of the encryption. So when a user logged in, she could populate the new column as well. Over time, she could switch from the old encryption to the new encryption and need to rely on the Boost database for that. She made some changes in the Boost application as well. So she hid all the authentication related stuff in Boost application. Boost didn't need to see password or email as usernames. Email is still there if Boost needed to send emails to the users, but there was no notion of user ID when referring to that email. So another thing that she learned from the future was that some users need to be part of multiple organizations. Also, each organization which represents a customer could also buy licenses for different services. So there was a new notion of a service provider or SP. So you have the organization which represents the customer bought some of the services and was the user. So each organization could have multiple users. Each organization could have one or more services they paid for. So every time an organization bought a license for one of the services that were registered BoostAuth, that service was added to that organization. She also decided that none of the services need to have any UI dealing with authentication related stuff. So she moved all those pages to BoostAuth as well. So admins could add users to the organization and they could also assign those users to different services. So if it was a user called Chloe, which belonged to organization 1, and they have both Boost and Boost Graph, the admin could decide this user could have access to both. So that user have relations to both service provider records. But the admin could decide this user could only have access to Boost or just Boost Graph. So now, during the authentication, what happened was a user started on a service like Boost or Boost Graph, and they will send the user Boost to authenticate. Here's the login page in Boost. So they can enter their information and Boost will check their username and password and send a SAML response back to Boost or Boost graph based on whatever they start with. In this case, they started Boost. So if they are authenticated properly, they could access Boost. But the new sample response had some extra information. So the extra information was if the authentication was successful, and the second extra information was if the user actually authorized for that service. So the user could exist in BoostAuth, but they might not have access to a specific service. So when Boost ACS endpoint received the SAML response, it decided, oh, if the authentication was successful and the authorization was also true, they could access the service. If any of those were false, Boost didn't give access to the user. So the SAML response also contained the UUIDs of the user and its organization. So this extra information helps us to see if the user already existed in its own database. If it's not, Boost could create the user and org using those UUIDs. So for a service provider, the only thing that was meaningful were those UUIDs. So they knew this user with UUID XXX belongs to the organization with UUID YYY. And if they existed, all is good. If they didn't, probably it's a new user. If the user was authenticated but not authorized, they could have checked the database, say, oh, this user used to be here but not authorized anymore. They could remove it from their own database as well. So that was a passive way for dealing with user and organization related stuff. But Chloe decided some services might want to be more proactive. So she could actually implement a way for them to be informed when authentication and authorization information was changed in BoostAuth. So each service could register a webhook with BoostAuth. And that webhook would be an endpoint to be called when any authentication authorization related to the specific service is changed on BoostAuth. So if an admin added the user there with access to Boost service, or remove them, or move them, and BoostAuth would call that webhook, sending them information about the changes there, so they could update their internal representation of users and organization, which only included the UIDs. But with this design, the user ID that the user used, their email, to log in was only a concern for BoostAuth. If they change it, it didn't change anything about the presentation of the user and services they could have access to and the organizations they belong to. So it was only changed in one place in BoostAuth. There's no need to synchronize that piece of information between multiple services. So after all these changes, she traveled in time. In the future, users were much happier in this version of her future. But behold, the lack of toilet paper again, a part she couldn't do much about. So, going to summarize what they learned. So they learned that sometimes standards are not the best things to go with if they are not adopted in many places, and they might actually make your life more miserable. Synchronization between multiple services with the authentication related information is not a good idea. If you centralize that information in one place, the need for synchronization is going to go down considerably, and it will make your life much easier. So at the end of this presentation, I just want to thank our friends and coworkers, Cisco. So I want to especially thank Sohan for brainstorming the initial draft of this, and Jonathan for providing me with the adorable hedgehog pictures. If you have any questions, you can contact me. My email address. Stay safe.